sorting algorithms, the same numbers. One finishes in a blink. The other is still figuring out where to start. But here's the twist. The winner changes depending on the data. Watch. On the left, Insertion Sort, the card player. It picks up one number at a time and slides it into place. Simple, patient, a little old-fashioned. And on the right, quicksort, the gambler. It splits the data, picks a pivot, and bets everything on speed. On average, quicksort is one of the fastest algorithms ever written. So this should be easy, right? Random data, 50 numbers, totally shuffled, and it's not even close. Quicksort tears through it. Divide, conquer, done. Insertion sort, still shuffling cards near the start. Final count? Quicksort wins by a landslide. Case closed. Quicksort is king. Or is it? Here's a question nobody asks. What if the data is almost sorted already? Not random, just a few numbers out of place. The kind of data you actually see in the real world. Let's run it again. Same two algorithms, same start, but watch the card player now. Insertion sort glances at the list, sees it's nearly done, and finishes. 4 comparisons. 4. Meanwhile, quicksort doesn't know the data is almost sorted, so it does all its work anyway. Over 1,000 comparisons. The gambler just got humiliated by the old-fashioned card player. 40 times slower. So why did it happen? Quicksort's genius is splitting chaos apart, but here there's no chaos left. So all that splitting is wasted effort. Insertion sort just walks through and confirms what's already true. The lesson? There is no best algorithm. There's only the best algorithm for your data. So if quicksort isn't unbeatable, what about merge sort? It makes a promise the others can't. It's never slow. Same speed every single time, no matter what you throw at it. On random data, they go head to head. Merge sort, calm and consistent, matching quick step for step. 2 different strategies, almost the same result. So who actually wins? Nobody and everybody. It depends on the data, and now you know how to think about it. Next time, I raise the 2 slowest algorithms ever made. It's painful. Subscribe so you don't miss it.